As global concern about climate change increases and its potential impact on food security becomes more apparent, there is an urgent need for innovative solutions that address these issues holistically and sustainably. This proposal presents a unique approach to reuse oil palm byproducts, namely oil palm boiling ash, OPBA, and oil palm boiling clinker, OPBC, to produce an innovative novel fertilizer formula. By transforming these oil palm byproducts, we aim not only to counter the effects of climate change, but also to increase agricultural yields, improve soil health, and reduce reliance on chemical fertilizers. This multi-pronged strategy provides a coherent response to the interlinked challenges of climate resilience and sustainable agriculture, particularly in the oil palm industry in Malaysia. From 2020 to 2021, Malaysia's dependence on imported mineral or chemical fertilizers increased by 60%, resulting in an additional expenditure of $17.8 million in 2021. This increased dependence creates urgent environmental and economic challenges. Concurrently, Malaysia's oil palm industry produces approximately 12 million tons of oil palm boiling ash, OPBA, and oil palm boiling clinker, OPBC, annually. These byproducts, which are generated from the combustion of oil palm shells and EFB to generate electricity for the milling process, are predominantly disposed of in landfills due to their limited usage. This increasing disposal practice poses significant environmental and health risks. As global demand for oil palm increases, sustainable approaches are urgently needed to address both Malaysia's increasing reliance on imported fertilizers and the escalating challenges associated with oil palm byproduct management. Now we will show you the process of producing NK bio-fertilizer. Raw material OPBA and OPBC. The raw material made from empty fruit bunches, palm shell and mesocarp fiber. MOP muriate of potash, the source of K, potassium. The raw material put into batching machine for rationing according to the formula. SOA ammonium sulfate, the source of N, nitrogen. The raw material put into batching machine for rationing according to the formula. OPBA and OPBC bio raw material, source of bio-organic. The raw material put into batching machine for rationing according to the formula. Ongoing to mix the raw materials. Blending the three raw materials using mixer machine. Blended materials. First batch from granulator machine. Compaction. The blended materials are compacted into sheets or ribbons and then broken into granules or pellets using rollers or other equipment. Screening. The granules may be sieved or screened to separate them into different size fractions. Second batch from granulator machine. Finished product on conveyor. Finished product into batching machine. Store into jumbo bag. Here are the 5 benefits of compacted compound fertilizer. Repacking fertilizer. Quality control. Conduct quality checks to ensure the final product meets the specified nutrient content, granule size, and other quality parameters. Fertilizer sampling. Ensuring that it meets the specified nutrient content, physical characteristics, and safety standards. Hardness test. Assess the physical characteristics of the fertilizer, including granule hardness. Moisture content. Measure and control the moisture content of the fertilizer to prevent caking, nutrient degradation, and microbial growth during storage. Economic impact. Utilizing locally available oil palm byproducts to produce fertilizer can reduce Malaysia's dependence on imported fertilizers. This can potentially lead to substantial cost savings both for individual farmers and the nation's economy. Besides, the transformation of oil palm byproducts into a valuable agricultural resource can lead to the emergence of a new industry. Environmental impact. The project addresses the challenge of managing the enormous amounts of oil palm byproducts produced annually, which are currently being disposed of in landfills. Redirecting these byproducts to fertilizer production reduces landfill waste, lessening the environmental and health risks associated with it. Moreover, the ability of oil palm boiling ash, OPBA, and oil palm boiling clinker, OPBC, to act as a long-term sink for atmospheric CO2 provides a dual benefit. It contributes to the global efforts in fighting climate change and improves the climate resilience of agricultural practices. Additionally, by decreasing reliance on imported fertilizers, the carbon footprint associated with transportation and associated logistics can be reduced. Agricultural impact. The novel fertilizer enhances critical soil properties like water retention, aggregation, pH balance, and fosters beneficial biological interactions. This results in healthier soils that can support diverse crops and improve yields. By ensuring the controlled and steady release of essential nutrients into the soil, the compound fertilizer is poised to significantly improve crop yields. This can translate to increased profits for farmers and enhanced food security for the region. In addition, incorporating oil palm byproducts in the fertilizer formulation allows for a reduction in the proportion of chemical ingredients. This can lead to fewer chemical residues in the soil and on crops, promoting more sustainable and environmentally friendly agriculture. Social impact. Reducing the disposal of oil palm byproducts in landfills can mitigate the associated health risks for communities living nearby. Furthermore, a decrease in chemical fertilizer use can lead to healthier crops and reduce potential health risks linked to chemical residues. The project also serves as a tangible example of circular economy principles, where waste products are given a new life. It can serve as a case study and educational tool to raise awareness about sustainable practices and the importance of innovative solutions in addressing global challenges. Sustainability. 1. Circular economy model. 2. Reduced environmental footprint. 3. Soil health and preservation. 4. Ecosystem resilience. 5. Economic self-reliance. Scalability. 1. Ample raw material supply. 2. Adaptability to different crops. 3. Technology transfer potential. 4. Potential for diversified products. The use of these byproducts not only addresses waste management issues but also introduces a sustainable mechanism to bolster agricultural practices. Given the increasing demand for oil palm globally and the resultant byproducts, the scalability of this solution is vast. Moreover, introducing this solution can create a circular economy within the oil palm industry where waste is continually repurposed, reducing environmental footprint while sustaining agricultural growth.